These are the notes for 2.1, Introduction to Fractions. And the words that we went over were numerator and denominator. And remember that the numerator is a top part of the fraction, or the number of parts being considered. And denominator is a number of equal parts, which is a 5. In this case, it's 3 over 5. So we have 5 equal parts, and the number of parts that we're considering is 3. And I asked you to illustrate this in class. And so what we did is we shaded 3 parts since we have 3 that are being considered out of 5 equal parts. So this is going to model 3/5. So now in example 1, I did ask you to identify the numerator and the denominator. The 5 tells you the number of equal parts. In this case, it's denominator. And the 7 is the numerator. So I'm going to use N and D to denote numerator or denominator. 15 is the number of equal parts, and the number that are being considered are 11. That's the numerator. 7 was the one that we were kind of not sure, but we said that 7 over 1, and we have that 1. 7 can be expressed as 7 over 1, so 1 is the denominator, and 7 is the numerator. The next couple of fractions I did ask you to simplify. And so we have 3 as a numerator and 3 as a denominator, and that's going to give us a whole. That's going to give us 1, which is a whole. We have 6 as a numerator, and we have 0 as a denominator. 0 means that there's no equal parts. So there's no equal parts, we can't do anything about it, so that is going to be considered to be undefined. Now, the third fraction, we have 6 equal parts and we have 0. If I had to give an illustration, we'd have a pizza, 6 equal parts, and there's none left. So this would be 0. An improper fraction is when a numerator is larger than the denominator. So what I asked in class, I told you, think of one pizza and how many equal parts do we have? And of course, we have 4. In this case, how many are we considering? We got to count the slices. Of course, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Of course, 1 is taken or 1 was eaten, so it's 11 over 4. The next part of the lesson I asked you, we'll express this as a mixed number or a mixed fraction, which means we're talking about whole and a fractional part. So in this case, we have 2 whole pizzas, and you can see the 2 whole pizzas. We're still talking about 4 equal parts. On the last pizza whole is missing 1 slice, so it's 2 3/4. In this example, I asked the class, or asked you, identify this as a proper, improper, or a mixed number. In this case, 6 over 7 is considered a proper fraction because the numerator is less than the denominator. 1 6/8 is a mixed number because it has 1 as a whole, and then it has a fraction 6 over 8. There's a fractional part. 13 over 12 is considered an improper fraction because 13 is larger than the denominator, 13 over 12. And then the last one, we have 99 over 100, not quite 100. This is considered to be a proper fraction. In order to write this mixed fraction as an improper fraction, there is an algorithm or there's a process. And what you're going to do is you're going to get the denominator of the mixed fraction or the mixed number. In this case, you have 9 times 4 plus 2. And then what you're going to do is you're going to divide by the denominator, which is 9. In this case, 9 times 4 is 36, plus 2 is 38. So it's going to be 38 over 9. That's the improper fraction. So 4 and 2 ninths is equal to 38 over 9. The fraction 1 and 8 elevenths can be written as a mixed fraction. You got to multiply 11 times 1 plus 8. So in this case, we're going to write 11 times 1 plus 8 divided by 11. So we have 11 times 1 is 11 plus 8 gives you 19 over 11. So we're going to say that 1 and 8 elevenths is equal to 19 over 11. Now what we're going to do is we're going to write the mixed number, we're going to write the following fractions as a mixed number or whole number. So we have 30, we're going to do long division, 30 divided by 7. 7 times 4 is 28. You're going to subtract 30 and 28, which gives you 2. And this is our remainder. So you have 4 and then your remainder over 7. So 30 divided by 7 is 4 and 2 sevenths. The next one we had 84 divided by 6. So we have 6 times 1 gives us 6. We subtract, so we have 2. Bring down the 4. 6 times 4 gives you 24. So we notice that a remainder is 0. So what is this equal to? 14, which is a whole number.